In this video, I'd like to look at some examples of how we find the area of a trapezium. We know that in a trapezium, one pair of opposite sides are parallel. Also, remember that the interior angles of a trapezium always add up to 360 degrees. When working with quadrilaterals, we use the interior angles of a quad as our reason. To find the area of a trapezium, we use the equation area is equal to 1 over 2 multiplied by a plus b, all multiplied by the perpendicular height. Here, a and b are the lengths of the two parallel sides. So in this case, a could be the length of AB, and b could be the length of DC. But please be careful. The perpendicular height is not the length of one of the sides of the trapezium. To find the height, we draw a dotted line from the bottom to the top of the trapezium, perpendicular to the base, which in this case is CD. Let's look at some examples of how we find the area. In the sketch below, JK is equal to 10 centimeters and LM is equal to 15 centimeters. Calculate the area of the quadrilateral JKLM. From the diagram, we can see that JK is parallel to ML because of the arrows over here and over here. We are working with a trapezium, and to find the area, we use the formula area is equal to 1 over 2 multiplied by a plus b, all multiplied by the perpendicular height. Remember that a and b take on the values of the two parallel sides. So let's say that a is the length of side JK, which is 10 centimeters, and b is the length of side ML, 15 centimeters. The perpendicular height is the dotted line that runs perpendicular to the base ML. The diagram shows us the perpendicular height is 5 centimeters. So now we can write our equation. The area is equal to 1 over 2, open our bracket, A, which we said is 10 centimeters, plus B, 15 centimeters, close the bracket, multiplied by the perpendicular height, which is 5 centimeters. Now let's add the values in the bracket. We have 1 over 2, open our bracket, 10 plus 15 is 25, close the bracket, multiplied by 5. Now we can take our calculator and we can say 1 over 2 multiplied by 25 multiplied by 5 is equal to 62,5. So the area of this trapezium is 62,5 centimeters squared. Let's do one more example. The sketch below shows trapezium TUVW. TU is parallel to VW. TX is drawn perpendicular to VW. TU is 10 meters. TW is 5 meters. WX is 3 meters. And XV is 12 meters. Calculate the area of the trapezium TUVW. Again, we need to find the area. So we use the formula 1 over 2 multiplied by a plus b multiplied by the perpendicular height. Now we need to determine the values of a, b, and the perpendicular height. The question tells us that side TU is parallel to side VW. So the lengths of these sides will take on the values of A and B. The diagram shows us that TU is 10 meters. So let's make a note of this up here. This is the value of A. Now let's look at VW. From the diagram, we can see that VW runs from V to X and then from X to W. So VW is the entire length, 12 meters plus 3 meters, which gives us a total of 15 meters. So let's make a note up here. that VW is 15 meters. This will be our B value. Now we need to find the perpendicular height. The perpendicular height of the trapezium is not the length of TW, but rather the length of the dotted line TX. So let's make it red. TX is perpendicular to the base VW. So there is a 90-degree angle at X. And we can see this on our diagram over here. This means that TXW is a right angle triangle. So we can use Pythagoras to find the length of TX. Let's make the whole triangle red. Here, TW is the hypotenuse of the triangle because it lies directly across from the 90-degree angle. So to find the length of the unknown side, we can say TX is equal to the hypotenuse, TW, squared, minus the third side, WX, squared, all under a square root. We know that TW is 5 meters, so we can say 5 squared, minus WX, which is 3 meters, 3 squared, all under a square root. Now we can take our calculator. We can say the square root of 5 squared minus 3 squared is equal to 4. This means the perpendicular height is 4 meters long. So let's make some space. And we can make a note up here that TX is equal to 4. Now we have values for A, B, and the perpendicular height. So we can use this to find the area of the trapezium. So we can say the area is equal to 1 over 2, open our bracket, our value of A, 10, plus B, 15, close the bracket, multiplied by the perpendicular height, which is 4. Let's add the values in the bracket. We get 1 over 2, 10 plus 15 is 25, close the bracket, multiplied by 4. Now let's put this into our calculator. We can say 1 over 2 multiplied by 25 multiplied by 4 is equal to 50. The area of the trapezium is 50 meters squared. And we have now completed this question.